Hello everyone. Today we shall discuss about squares and square roots of chapter 6. Today we will give the introduction of squares and square roots. Here is the introduction. You know that the area of a square is equal to side into side, where side means the length of a side. Study the following table. Square, side of a square in centimeter 1. Area of the square is equal to 1 into 1, that is 1 square. 2 into 2, that is 2 square. 4. 3 square, 9. 5 square, 25. 8 square, 64. A into A square. What is special about the numbers 4, 9, 25, 64 and other such numbers? Since 4 can be expressed as 22, that is 2 square. 9 can be expressed as 3 into 3, 3 square. All such numbers can be expressed as the product of the number with itself. Such numbers like 1, 4, 9, 16, 25 are known as square numbers. In general, if a natural number m can be expressed as n square, where n is also a natural number, then m is a squared number. Is 32 a square number? No. We know that 5 square is 25, 6 square 36. If 32 is a square number, it must be square of a natural number between 5 and 6. But there is no natural number between 5 and 6. Therefore, 32 is not a square number. Consider the following numbers and their squares. Number 1 square is 1 into 1, 2, 2 into 2, 3, 3 into 3, like this, 4 into 4, 5 into 5 square. From the above table, we must enlist the square numbers between 1 and 100. Are there any natural numbers between up to natural square numbers up to 100 left out? You will find that the rest of the numbers are not square numbers. The numbers 1, 4, 9, 16 are square numbers. These numbers are also called perfect squares. These are also called perfect squares. Properties of square numbers. Following table shows the squares of numbers from 1 to 20. Here you see 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, 4, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225, 16 square 256, 17 square 289, 18 square 324, 19 square 361, and 20 square 400. Study the square numbers in the above table. What are the ending digits, that is, digits in the ones place of the square numbers? All these numbers end with 0, 1, 4, 5, 6 or 9. Here you see all these numbers end with 1, 4, 6, 9 or 1 in the units place. None of these end with 2, 3, 7, 8 at units place. Can you say that if a number ends in 0, 1, 4, 5 or 6 or 9, then it must be square number? Think about it. Can you say whether the following numbers are perfect squares or not? How do you know? Now you see, study the following table of some numbers and the squares and observe the ones placed in both. 1 square is 1, 2 4, 3 square 9, 4 square 16. These are all squares. 21 square is 441, 22 square is 484, 23 square is 529, 24 square is 576, 25 square 625, 30 square 90, 35 square 1225, 40 square 1600, 45 square 2025, 50 square 2500. The following square numbers end with digit 1. The following square numbers end with digit 1, 81, 121, 361, 441, that is 1 square is 1, 9 square 81, 11 square 121, 19 square 361, 21 square 441. Write the next two square numbers which end with in 1 and their corresponding numbers. You will see that if a number has 1 or 9 in the units place, then its square ends with 1, obviously. Let us consider square numbers ending in 6. 4 square 16, 6 square 36, 14 square 186, 16 square 256. Right? You can see that when a square number ends in 6, the number whose square it is will have either 4 or 6 in unit, either 4 or 6 in unit place. This is the properties, right? Can you find more such rules by observing the numbers and the squares? That is table 1. Consider the following numbers and the squares: 10 square 100, 20 square 400, 80 square 6400, 100 square 1 0 0 0 0, 200 square 300, 700 square 900 square. If a number contains 3 zeros at the end, 3 zeros at the end, how many zeros will have its square? How do you notice about the number of zeros at the end of the number and the number of zeros at the end of its square? Can you say that the square number can have only even number of zeros at the end? Even number of zeros at the end. Yes. See table 1 with the numbers and the squares. What can you say about the squares of even numbers and squares of odd numbers? Some more interesting patterns. Now we will study about the patterns. Do you remember triangular numbers? Numbers whose dot patterns can be arranged as triangles. 1, 3, 6, 10, 15. If we combine two consecutive triangular numbers, we get a square number like this. 1 plus 3, that is 4. 1 plus 3, that is 4. 3 plus 6, that is 9. 6 plus 10, 6 plus 10, that is 16, 4 square. Numbers between square numbers. Let us now see if we can find some interesting pattern between two consecutive square numbers. The 1 square, 2, 2 square is 4. The two non-square numbers between the two square numbers is numbers, that is 2 and 3. 3 square, this is 9. 5, 6, 7, 8. The four non-square numbers between the two square numbers, that is 4 and 9. 2 square and 3 square. This one and these are non-square numbers. 6 non-square numbers between the two square numbers, that is 3 square and 4 square. You see the non-square number 10, 11, 12, 13, 14, 15. This you see 5 square. 8 non-square numbers between the two square numbers, 4 square and 5 square. These are non-square numbers. Between 1 square and 2 square, there are non-square numbers 2 and 3. Between 2 square and 3 square, there are 4 non-square numbers 5, 6, 7, 8. Now 3 square 9, 4 square 16. 4 square minus 3 square equal to 16 minus 9, that is 7. Between 9 and 16, there are between 9, 3 square and 4 square, the numbers are 10, 11, 12, 13, 14, 15, that is 6. Non-square numbers which is 1 less than the difference of the two squares, less than 1 bit. Right. Now we have 4 square, 16, 5 square, 25. 5 square minus 4 square is equal to 9. The numbers are 17, 18, 24, that is 8 non-square number which is 1 less than the difference of the two squares, 9 minus 1. Consider 7 square and 6 square. Can you say how many numbers are there between 6 square and 7 square? Yes. There is 7 minus 1. Right? If we think in a natural number n and n plus 1, then n plus 1 whole square minus n square is equal to n square plus 2n plus 1 minus n square, that is 2n plus 1. We find that between n square and n plus 1 whole square, there are 2n numbers which is 1. 2n numbers which is 1 less than the difference of the two squares. 2n numbers which is 1 less than the difference of the two squares. In general, we can say that if there are 2n non-perfect squared numbers between the squares of the numbers n plus 1, check n for 5, n for 6, etc. and verify. Right? In general, we can say that there are 2n non-perfect squared numbers between the squares of the numbers n and n plus 1. Now adding odd numbers. Consider the following. 1. Add 1. 1 square is 1 square, that is 1. 1 plus 3, sum of two first odd numbers, that is 4, that is 2 square. Sum of first three odd numbers, 1 plus 3 plus 5, that is 3 square. 9. 1 plus 3 plus 5 plus 7. 4 square 16. Then 5 square 25. 6 square 36. So you can say that the sum of first n odd natural number is n square. You can say that the sum of first n odd natural number is n square. Looking at it in a different way, we can say that if a number is a squared number, it has to be the sum of successive odd numbers starting from 1. Successive odd numbers starting from 1. Consider those numbers which are not perfect squares, say 2, 5, 2, 3, 5, 6. Can you express these numbers as the sum of successive odd natural numbers beginning from 1? You will find that these numbers cannot be expressed in this form. Consider the number 25. Successively subtract 1, 3, 5, 7, 9 from it. 25 minus 1, 24. 24 minus 3, that is 21. 25 minus 5, 16. 16 minus 7, 9. 9 minus 9, 0. This means that 25 is equal to 1 plus 3 plus 5 plus 7 plus 9. Also, 25 is a perfect square. Now consider another number 38 and again do as above. 38 minus 1, 37, 38, 7 minus 3, 34, 34 minus 5, 29, 29 minus 7, 22, 22 minus 9, 13, and 13 minus 11, 2, 2 minus 13, that is minus 11. This shows that we are not able to express 38 as the sum of consecutive odd numbers starting from 1. Also 38 is not a perfect square. So we can also say that if a natural number cannot be expressed as a sum of successive odd natural numbers starting from 1, then it is not a perfect square. We can use this result to find whether a number is a perfect square or not. A sum of consecutive natural numbers. Consider the following: 3 square 9, that is 4 plus 5. First number 3 square minus 1 by 2. Second number 3 square plus 1 by 2. 9 plus 1, 10 by 2, 5, 4 plus 5, right? Sum of consecutive natural numbers. The sum of consecutive natural numbers 4 plus 5. 5 square 25, 12 plus 13. 7 squares 49, 24 plus 25. Consecutive natural numbers. 9 square 81, 40 plus 41. 11 square 121, 60 plus 61. 15 square 225, 112 plus 113. Express the following as the sum of two consecutive integers. Do you think the reverse is also true? Is the sum of any two consecutive positive integers is perfect square of a number? Give examples to support your answer. Product of two consecutive even or odd natural numbers. 11 into 13, 143. That is 12 square minus 1. 11 into 13 equal to 12 minus 1 into 12 plus 1. Therefore, 11 into 13 equal to 12 minus 1 into 12 plus 1, that is 12 square minus 1. 13 into 15, 14 minus 1 into 14 plus 1, that is 14 square minus 1. 29 into 31, 30 minus 1, 30 plus 1, that is 30 square minus 1. 44 into 46, that is 45 minus 1, 45 plus 1, or 45 square minus 1. So in general, you can say that a plus 1 into a minus 1 equal to a square minus 1. A plus 1 into a minus 1 is a square minus 1. Some more patterns in square numbers. See these patterns also. After the squares of numbers 1, 11, 111, etc., they give a beautiful pattern. 1 square is 1, 11 square 1 to 1, 1 1 square 1 2 3 1 2 1, 1 2 3 4 3 2 1, 1 2 3 4 5 4 3 2 1, 1 2 3 4 5 6 7 8 7 6 5 4 3 2 1. Another interesting pattern: 7 square 49, 67 square 4489, 667 whole square 444889, 6667 square 44448889, 66667 square 4444888889, and 666667 square, like this. So all this pattern we get from this. The fun is being able to find out why this happens. Maybe it would be interesting for you to explore and think about such questions even if the answers come out some years later. Now you got different patterns also. You have to remember all these properties of squared numbers. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.